Hello, welcome to the CCNA course brought to you by Eduonics. This is Chapter 1, Video 3. We're going to be looking at some common applications and their impact on the network. Now, when you are a network administrator, it's obviously very important to block certain things on your network. It's also very important to make sure things are allowed as well. So here's the kind of top 8 things that are going to be going on your network that almost every single business is going to be using. So every time you switch your computer on, you see a number of applications running in the background, or ones that you've opened, from the operating system to small utilities, anything like that. They're all classed as network applications. A networked application is an application that uses two components to run. One of its components runs on the local computer, and the other component runs on a network computer or a remote host to provide communication to the host running on the local computer, almost like a client-server kind of scenario. The networked application mostly use the internet and other network hardware to perform their tasks. The web browser is an example of a networked application. It uses application layer protocols such as HTTP, SMTP, and FTP to communicate with servers and applications. Many times a protocol and its application are so closely tied with each other that it's difficult to separate them. For example, the applications such as Telnets, Dhcp, FTP, and Snmp are all networked applications that are very closely tied to the protocols that they're using. A web browser, which is also a web application, allows you to type a URL into the address box and it takes you to the destination page using either HTTP or HTTPS protocols. The web browser first connects you to the server referred to in the URL by resolving the DNS name with the IP address that you are requesting of the server. The browser then sends HTTP GET requests to the server and requests the path information. The server responds to the request with a file that points to other files such as images and fonts and things like that, which are all found on the same server. The browser then reads the file and opens the desired URL. The HTTP URL changes to HTTPS when a secure website needs to be opened. So some other kind of common network applications here. Email application such as Outlook would use SNMTP and POP3 protocols to send and receive messages to and from email protocol servers. And when you send an email message, the client that you use to send the message to the email server using SMTP protocols, the email server reads the domain name of the destination email server and then sends a message to that server. If the server with the specified domain doesn't exist, then the message is returned back to the email client. And if the message delivered to the email server is spooled or queued on the destination server, then the destination server checks the queue and delivers the message to the destination email account. And then the email client uses POP3 protocol to download the message or receive the email. And then moving swiftly on, we have FTP, File Transfer Protocol. It uses FTP protocol to transfer files between two computers. The FTP uses an FTP client on a computer and an FTP server in order to operate. The client initiates the FTP process by accepting the username and password and creates an FTP session. It can be left in anonymous mode, which isn't a good idea because it means anybody can log into it. The client initiates the files from the FTP server. It changes directories, it can list files, it can transfer files, it can pull files, push files, you name it, it can do it. And although you can upload and download using HTTP protocols also, FTP is typically used for transferring larger files and faster throughput. Then we have good old NTP. NTP is used for keeping time across networks, network time protocol. They have different root servers which are up on like higher web servers within the internet, and they filter down, and then you have certain ratings of NTP server depending on how close you are to a root server. We'll cover this a bit more when we look at setting devices up and we look at pointing them to our own NTP servers, that kind of thing. And then we have, after NTP, we have DNS. DNS resolves fully qualified domain names or host names to their IP addresses. It allows to access websites by typing in their friendly names, as it's called, such as google.com instead of their IP address. And typing it in a browser will allow you to access the website. The use of DNS allows you to change the IP address of a website as often as you want, because it allows you to use domain names instead of IP addresses. And then you have, we'll skip down a bit actually, we'll just do the very bottom one first. We'll do DHCP, Dynamic Host Control Configuration Protocol. It allows you to assign IP addresses to the host computer on your network dynamically. In the absence of DHCP, each computer on a network needs to be assigned a unique IP address manually. The manual assignment of IP addresses become a pain when a computer moves to a different network segment in a large network and needs to be assigned a different IP address. In large network environments, the dynamic assignment of IP addresses eases the administrator's task of managing IP addresses, as you can well imagine. So Snmp, Simple Network Management Protocol, is used mainly in network devices for controlling and reading information for remote monitoring and remote administration. You can also use it for a whole host of other things. You can do Snmp walks across devices to see what information is being listed, and as long as you have a particular MIB for a device, which is almost the code you need for that device to display information from it, you can interrogate it all you want. You have Snmp v2, which is a bit more secure and requires some kind of authentication as well. So SNMTP and POP3 we've already talked about. These are all the common applications on the network that you have to think about when it comes to management of the network, as I say, not just for blocking but for allowing, depending on how you set up your firewall. Really, you should have an entire kind of block all policy and then poke holes in it like Swiss cheese for what you want, rather than having open everything and then block all the certain ones that you don't want, because that is almost an impossible task. You don't want to start down that path, because once you do, it takes a lot to reverse it again. So make sure you get your firewall set up and you have your network management set up properly from the word go.